Okay, we'll start today's session. Okay, in last session we had discussed about different terminology related with the electrical network. We had seen different definitions related with the electrical network, such as what is meant by loop, what is meant by mesh, what is meant by node, okay, what is meant by junction, and so on. Right? And we had already started what are the different types of sources are available in the electrical network. Right? We had discussed two types of electrical sources we have. One is a independent source, another is a dependent source. In independent source, we had seen there are two types. One is a voltage independent source and another is a current independent source. Okay, in independent source, your voltage or current source is not depending on the external condition parameters, right? And we have started what are the different types of dependent sources are available in the electrical network. Dependent source are categorized again two groups: dependent voltage source and dependent current source. Okay, then this dependent source again categorized into different groups, right? Voltage control voltage source, current control voltage source, voltage control current source, and so on, right? There are four types, okay, that we have seen already, right? We had covered two types, right, in dependent sources. One is what? One is your voltage controlled voltage source and another is a current control voltage source, right? What is meant by voltage controlled voltage source? Means your voltage source whose the magnitude and polarities are dependent on the magnitude of polarity of some other voltage present in the network. That is called as a voltage control voltage source. And what is meant by current control voltage source? Your voltage source whose the magnitude and polarity are dependent on some current and magnitude direction in the in particular network. That is called as a current control voltage source. That two types we had already seen in the previous lectures, right? Today we start again two remaining dependent sources, that is called as a current controlled current source and another is a voltage controlled current source. Then we'll see what are the different basics laws are available in electrical network, such as your Ohm's law, KVL, KCL, what is meant by voltage divider rule, current divider rules, and so on. That we'll see today's lecture. Right. So I'll share my screen. Okay, my screen is visible to all of you. Unmute one,
Yes, sir.
Yes, sir.
then fine.
Mm.
Okay, then third type is dependent sources is your current current controlled
Yes.
current source. That is ICIS. This is the third types of dependent sources, right? In that your current source is your what current. That current source whose the magnitude and directions are controlled by the magnitude and direction of some other current in the present network. That is called as a current controlled current source, right? Means your main source is what? Your main source is your current source, but that current
Give me.
source huh.
Sir, some
Yes.
students are not doing. Can you please admit them?
I already enable the setting. Those who have joined, those who are willing to join the meeting, now they are directly automatically admitted. I already enabled
But
this setting.
they are just
People
fixing
are
that.
okay. Then I'll stop my sharing. Then we'll see. Right. 36 are joined right now. 36
But there
people
are
are
still
joined.
10 to 15 students yet to come.
They are not joined it maybe because I already enable the setting. People, those who are willing to join, na, they can directly click on join the meeting. They can easily admit it without my consent. There is no need to Terna. In those who have don't have a Terna email ID, na, they can join another mail also. There is no problem. 36 are there. Ayushi.
Yes, sir.
Yes, sir.
36 are there. People are waiting for my side. Actually, my consent.
Yes, sir. There are some people who cannot join the lectures.
No, no, it's not showing in my system actually. 36 are there actually. So we can
So
start.
total strength is 58.
58, but still 36 are joined right now.
Yes, sir. There's a boy named Atharva Pawar. He's been trying it for from 11 to.
But there is no problem from my side actually. Yeah? There is no problem from my side.
There are
How you
many students.
how you can join then? Suppose if problem is from my side, then how you can join? I am right or wrong? Hello, Ayush.
Yes, sir.
So what we have to do? Shall we start or
Yes,
shall we
sir. You
wait?
should. You start, sir. Let's see what happens. There might be some technical issue.
Then we started current control current source. Screen is visible. Screen is visible.
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Then here your source is what? Your source is current. That current source is depending on some current present in electrical network. That is called as a current control current source. Suppose if we see here the example, we have a current source, right? This is our current source. That current source is nothing but your K, we have to assume. Okay, some current are present or in electrical network that is nothing but your Ix. This current is also present in electrical network, right? And our main current source is also available in the network, that is K, and Ix is also present in electrical network. Means this current source K is depending on some other current present in the electrical network. Means that is K into your Ix. K into Ix. Means Ix is nothing but your controlling parameter. Means this current source is totally depending on whatever current present in the electrical network. The present current in the electrical network is Ix, right? Then next type is what? voltage controlled current source. Voltage controlled current source. In voltage controlled current source, the source is what? Your current source, right? Means current source whose the magnitude and directions are dependent on the magnitude and polarity of some other voltage in the network. That is called as a current controlled voltage controlled current source, right? Means main source is what? Your current source, but this current source is depending on magnitude and polarity of some other voltage present in the electrical network. That is called as a voltage controlled current source, right? Suppose if you see the example in that, the current, this is your current source. This is your current source K, right? Means this current source is depending on some other voltage present in the electrical network. Some other voltage present in the electrical network. Suppose if we assume here Vx, right? Vx, that is plus and minus over here. Means this current source is depending on some other voltage present in the electrical network. K into your X. This current source is depending on your some voltage present in the electrical network. What the voltage present in the electrical network is Vx. Means Vx is nothing but your what? Controlling parameter. Controlling parameter. Right. This is for four dependent sources we have seen. Two we have earlier seen, that is nothing but your voltage control voltage source. Second one is a current control voltage source. Third one is a current control current source. Fourth one is
Hello.
voltage control. Yes, yes, voltage control current source. These are the four types of dependent sources present in electrical network. I hope you have understood. Yes, have you understood or not? Anybody unmute and tell me. Is there any difficulty in that?
No, sir.
If you have any
No, sir, we
difficulty,
got it.
you ask. If you have any difficulty na, then you tell me. You unmute yourself and pinch me ki we have not understood this particular point, right? Don't, there is no problem. Okay.
Sir, what is second type?
Second type is a current control voltage
No, sir,
source.
no, sir. First is voltage control voltage source. Second is control current
Current control
current
voltage source.
voltage. Okay, sir.
Current control voltage source. Third one is current control current source. Fourth one is a voltage control current source. Right. Means source is what? Two times we have voltage source, but that voltage source is depending on your voltage and current. We have two current sources, right? And that current sources is depending on the current also, is depending on the voltage also. Clear? Okay.
Yes, yes, sir.
This is very important point actually for dependent sources. The maximum examples are in network theory is based on dependent sources, right? If you are not clear this point, the rest of things is very difficult for you, right? Just
Sir,
you have to keep in just you have to keep in mind our
sir,
voltage source is depending, or our voltage source or current source is depending on some other controlling parameter present in the electrical network, right? That's it. Yes, tell
Sir,
me.
sir, what represents the main current source and voltage source? The KIX or
Voltage
the other one?
K is nothing but your current source, and Ix is present in electrical network. That is also your current. That is also is current, right? K is nothing but your current, and Ix is also present in current. But this K is depending on your Ix. Clear?
Okay,
A
okay.
is depending on your Ix. Here is what? Here your current source is what? K in the fourth condition, right? Current source is what? Your K, but this current source is depending on your what? Voltage source. Some voltage source are present in electrical network. Which so voltage source is present in electrical network over here? Suppose if you assume here, we have assumed here Vx, means this current source is depending on your voltage, right? Clear? Clear?
Yes, sir. Yes, sir.
We move on next. That is a basics law of uh, different basics law of electrical network, right? First, in that we'll see the different basics law of electrical network, such as Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, and voltage divider rule, voltage current, current divider rule, right? Series combination, parallel combination. What is the concept of short circuit? What is the concept of open circuit? How source convert into the current converted into voltage, converted to current. That is called as the source transformations rules and so on. Right? That maybe you have studied already in basic electrical engineering. Just we have to
Yes, sir.
uh,
Yes.
just we have to go through some revision, right? Then rest of things will clear in further lectures. Okay. Then first is Ohm's law. What is meant by Ohm's law? Anybody unmute yourself and tell me. Ohm's law you have studied already. What is the statement of Ohm's law? Ohm's law is what? The register having resistance R, right? The register, whatever register we have used, that some resistance is there R, and some voltage is across flowing through the resistance. Means this voltage, whatever voltage across present in the resistance, that voltage is directly proportional to the current flowing. So it means the statement is what? For register having register R, the voltage across it is directly proportional to the current flowing. The we have represented in mathematical manner, that is V is equal to I into R. This is a simple statement of Ohm's law, mathematical representation of Ohm's law. Right? V is equal to IR. Means what is V here? V is nothing but your voltage drop across the resistor, right? And R is nothing but the constant of proportionality, that is called as a resistance. And I is nothing but your what is the current flowing through the resistor, right? Suppose if you take the example over here, this is your register having resistors R. Okay, the current flowing through the resistor is nothing but I. Here the polarity we have given positive to negative. This is a circuit symbol for a resistor with voltage and current flowing through it, right? Here, what you have showing over here, the left terminal is carries your positive potential, and right terminal you have carry the negative one, negative potential, right? Here negative potential, right? Means the left hand terminal uh, of R is at higher potential than right, and the potential difference is nothing but here ion. The potential difference is nothing but here ion. Right? Yeah. So we can also calculate what is the power dissipation in particular resistor. The power dissipation of resistor is nothing but your R is equal to what? I square R, R square. Or we can consider V square divided by your R is nothing but here V by R. Okay. Suppose I take the one example based on Ohm's law here. Suppose we have a resistor over here for 10 ohm, right? And current flowing through that resistor is 2 ampere. This is your voltage potential from positive to negative. Then you have to find voltage using Ohm's law. We can use directly simple what the voltage present in the particular network. Right? That is V is equal to I into R. Right? Means we
20.
have to find out. Then I are already known, that is 2 multiply by your resistance 10. What is here? That is 20.
20.
You have to keep in mind always, you have to use units in electrical network. Maximum people are forget. They simply write down the answers, but don't forget to mention the units. Right? Suppose voltage is there, you should mention always volt. The current source is there, you should always ampere. Right? If inductance is there, you always represented Henry. Right? Capacitance is there. You have to represent C, farad, microfarad. Right? Okay, the unit is a very must in electrical network. Without a unit, it can't be represented, right? So suppose if we assume the same over here, same registers, that is 10 ohm, right? 2 ampere current is there, but we have to consider the opposite polarity over here. Suppose if we flowing the current from negative to positive. Then what is the V over here? What is V over here? What is the V? What is the V?
20.
What is the V?
20.
How 20? Here V is not
Minus
20
20.
because
Yes, correct. Minus 20.
huh?
Minus 20.
Negative
Minus
minus.
20. Yes, exactly, minus 20. Because why? Since the polarity of
Polarity is
voltage
different.
is since the polarity of voltage V is opposite to our sign convention. We have always considered the sign convention from positive to negative, but here the polarity is V is opposite of our sign convention, right? So we can write V is equal to minus I into R, minus I into R, right? Minus 2 multiplied by your 10, that is nothing but what? Is this clear? Okay. Is this clear, Ohm's law? These things you have already studied, right?
Yes, sir.
Is this clear?
Yes, sir. Yes, sir.
Yes.
Then next point, are you not sleeping, na? People are not sleeping, na?
No.
You are not boring, na?
No, sir. No, sir.
Hello?
No, sir.
No.
Sure,
Yes,
Yes,
sir.
sir.
sure. Okay. You should always sit with your calculators, your notebook, and whatever I am explaining over here, na, you have to note it down. Okay. Yes. Then next, we'll see the what is Kirchhoff's law. That is KVL. Kirchhoff's voltage law. Anybody unmute and tell me what is KVL? You have studied already. In KVL is what is the algebraic sum of voltage around any closed loop in the network is zero. That is called as KVL. This is a statement of KVL. Statement of KVL is what? The algebraic sum of voltage around any closed loop. Algebraic sum of voltage around any closed loop in the network is zero. In the network is zero. That is the KVL. Okay, suppose if we assume here one electrical network, Suppose here two voltage sources are there, that is VA and VB. Okay, the three resistance are there, that is R1, R2, and R3. Okay, okay. Then we have to apply the KVL. How to apply KVL? We suppose in present electrical network there is, unmute yourself, please. Suppose this electrical network, you have to assume the current flowing in a loop. You can assume the current in arbitrary manner. There is no issue. Okay, that we have to assume the current is clockwise direction over here. This is our current flowing through the electrical network is I, right? I, and this current I is produce a voltage drop across R1, R2, and R3. Right? Suppose if we assign the polarity from positive to negative for this circuit, here we have assumed positive to negative. Here we have to assume positive to negative. Right? Means because of this current I is produce the voltage drop your R1, R2, and R3. That voltage drop across R1 is nothing but your V1. Voltage drop across R2 is nothing but your V2. Voltage drop across R3 is nothing but your V3. Right? Suppose if we start from point A here, this is we have assumed point A. Suppose if we starting from point A and we apply KVL to the loop in given direction, in given current direction. So what is first your voltage source is VA barabar minus your voltage across R1, that is minus V1, minus V2, minus V2, minus V3, plus the second one voltage source is VB. VB is equal to 0. That is your equation 1 we have assumed. Right? Here your two voltage source VA and VB, and then we have to assume the what is the voltage drop across the three resistors, that is minus V1, V2, and V3. Okay, then suppose the current I produce the voltage drop V1, V2, and V3. Suppose while the traveling loop direction, this voltage have drop in potential, from positive to negative. Means these voltage are given negative sign over here. It's minus V1, minus V2, and minus. This voltage drop in potential from positive to negative. That's why we have considered here minus V1, minus V2, and minus V3. Right? Suppose a VB is what? VB is from negative to positive. That's why we have considered VB is here positive. VB is here positive. Suppose we can write this equation as like this, that is you have to separate it out voltage source, that is VA plus VB is equal to your V1 plus V2 plus your V3. Right? That is equation number 2. Equation number 2 means here left hand side the summation of voltage rises are there, and right hand side this is summation of voltage rises, and this is right hand side we have to assume the voltage drop across the resistance. Then we can write KVL in this manner, right? That is the summation of voltage rises is equal to summation of voltage drop. So now you can see the equation number 1. In equation number 1 is what? Already we have written, that is VA minus V1 minus V2 minus V3 plus VB is equal to 0. But as per the Ohm's law, we can assume here V1 is equal to what? V1 is equal to I into R1. V2 is equal to what? I into R2. And V3 is equal to what? I into R3. Right. We can assume here equation number third. Okay. Equation number third. Right. Suppose we can simplify this equation VA plus that is summation of your voltage source VA is equal to VB, right? Minus you can take the common of current flowing through different resistors. The current common is I from R1 R2 R3, right? That is I R1 plus R2 plus R3 is equal to, okay, fine. Then what is our aim? Our aim is to find out the current I. You can separate it out is equal to your voltage sources VA plus VB divided by what are the resistance present in the electrical network, that is R1 plus R2 plus R3. That is equation. Yes, in these equations, VA plus VB is nothing but the total sources present in the loop, and R1, R2 and R3, this one, R1, R2 and R3 is nothing but the total resistance in the loop. Means, suppose this equation number 4 gives a current in a single loop current, right? This equation number 4 gives a single loop current. Means we can write also that is I is equal to total sources voltage in the loop divided by total resistance in the loop. Okay, then they you can easily find out what is the current flowing in that loop. This total resistance you can also assume RT, right? Suppose resistors are in the same current is flowing through that resistor. And suppose same current is flowing through the all resistors, then that connections we consider as a parallel connection. That connection is considered as a parallel connection. In series connections, the total resistance is obtained by adding the resistor which are in the series, right? The total resistance is what? Your total resistance is RT is nothing but RT. RT is nothing but this. This is your KVL. Okay. KVL means what? What is the statement of KVL? The algebraic sum of voltage around any closed loop in the network. Algebraic sum of voltage around any closed loop in the network is. Suppose we give the one examples to you people. A simple example I'll take here. Then I'm not writing here ohms, right? P, but it should be ohms. 3, 2 volt, 3 volt, 4 volt, 5 ohm, 10 ohm, 8 volt, 9 volt. Then our aim is here to find out the current flowing through 10 ohm resistor. Find out the current flowing through. You have to find out the current flowing through. This is 10 ohm resistor. You can find out and tell me what is the answer. You are ready. Are you solving or not? You should solve and tell me the what is the answer. What is the current flowing through 10 ohm resistor? Are you getting my questions or not?
Yes, sir.
Are you getting my question?
Yes, yes, sir.
Are you solving or not? You people are solving or not?
0.95
Huh?
0.95 ampere.
0.95 is not right answer.
Sir,
Okay.
point 7 ampere.
Yes, exactly. 0.7 ampere is your right answer. 0.7 ampere is a current flowing through 10 ohm resistance. Suppose if you assume the loop here from you have considered the polarity from positive to negative, again positive to here, positive to negative, here positive to negative, positive to negative, again positive to negative, from positive to negative here. Okay, when you apply the KVL, that is minus, suppose if you starting from here, minus 3I1I the current, minus 2 your voltage source here, minus 2 again voltage source is what, plus 3, minus 4, minus 5I1 the current flowing through the 5 resistor I, in minus 10 I, right, plus 8, plus 8, plus 9, and here your minus 4. Okay, this is your loop KVL, right? When you separated out the voltage source, we can simply separated out 8 plus 9. Then you have to take the common of current I is 2 plus 3 plus 10 plus 5. Then current is your I. We can take the common of I, right? Whatever we have seen in the previous, right? That is minus 2 minus, sorry, minus 2 plus minus 2 plus 3 minus 4. Then you can take addition of your voltage source 14 minus your current, addition you can do over here, minus 20 I equal to 0. Then you can calculate the current I is equal to your 14 by 20 is nothing but what, 0.7. Means whatever current flowing through this network, right? Whatever current flowing through this electrical network, the same current is flowing through this register. And means we have to find out what is the current flowing through in that loop. Is whatever current flowing through in that loop, the same current is flowing through. Right? Clear? This is a one of the simple example based on KVL. This concept is very important. If you don't know the concept of KVL, KCL, voltage divider, current divider, source transformation, this concept we can use repetitively in electrical network. People are don't know what is KVL and KCL. If you don't know the KVL and KCL, you can't be able to solve the examples of network. Should always keep in mind KVL, KCL. Suppose if you wrong KVL, rest of things will be wrong. Then you will get the 0 marks. Okay. So KVL, KCL, very important concept. Clear? Clear? Clear?
Yes, sir.
Yes, sir.
Then next concept is KCL. In KCL is what? What is KCL? KCL is nothing but the algebraic sum of all current entering at node is means the algebraic sum of all the currents. Algebraic sum of all the currents entering at the node is 0. Means KCL to the node is a sign. Suppose in KCL we have to assume or we have to assign positive sign for all incoming current and negative sign we have represented to all outgoing currents. All outgoing currents. The statement of KCL is what? The algebraic sum of current entering at node. Algebraic sum of current entering at one node is 0. It's all incoming current we have assumed as a positive sign, and all mm, we have represented as a negative sign. That you have. Okay, suppose if you take the example here, this is your I1, I2, I3, I4, and we have considered the node is N. Right. Here, what we have shown over here. Here, the current I1 and I2 are incoming to node N. Here, current I1 and I2. Here, current I1. Here, current I1 and I2 are entering at this node, right? At node N. Means hence this current I1 and I2 we have assumed as a positive, right? And while the current I4 and I3 and I4, I3 and I4 are outgoing. Is this current we have to assume as a negative current. Means the KCL is your positive sign for I1, positive sign for I2, negative sign for I3 because I3 is your outgoing current, and negative sign for I4 is equal to is the algebraic sum of all current entering at this particular node is 0 is called as a KCL. Right. Suppose if you take the example here. Okay, you find out here what is the current flowing through 10 ohm resistance. What is the current flowing through 10 ohm resistance by using KCL? KCL, the current are given, right? What is meant by the current flowing through 10 ohm resistance? Here we have to assume a point at KCL. You apply and tell me what is the current flowing through 10 ohm resistance by using a KCL. Yes. What is the current? Yes, yes. Aditi. Aditi Sati. Aditi is here. What is the answer, Aditi? Unmute yourself and tell. Unmute, Aditi.
Yes, sir.
Aditi. What is the KCL here? How to apply KCL here?
Um, 1 second, sir.
Aditi, what are the incoming currents and outgoing currents are present in the network? We discussed, right? For positive, for incoming current, we have considered as a positive sign. For outgoing current, we have considered as a negative sign as per the statement of KCL, right? Means in this electrical network, what are the incoming currents and outgoing currents you have to see here. The 3 ampere is what? That is the incoming current at the node P, right? Are
Yes,
you
sir.
getting?
Yes, sir.
3 ampere current is incoming towards KCL point P, right? But
Yeah.
4 ampere current is leaving from at node P. And again, for 10 ohm resistance, current is again leaving from the node P, right? Then we have to find out what is the current flowing through 10 ohm resistance. The direction is given for 10 ohm resistance is downward direction. That is outgoing current,
Downward.
right? Downward is means outgoing current,
Yes.
right? Means how to apply KCL then?
Um,
Are you getting or not, Aditi?
yes.
Gopal, Gopal.
Yes, sir.
Sir, can you show the
Uh,
question again?
Gopal, what is the current flowing through 10 ohm resistance?
Sir,
It's very simple, yeah. It's very simple. There is no logic behind it. You can just simple apply KCL to point P. Suppose if you have
P, sir.
incoming current at point P is what? Incoming current at point P is 3. That is
3.
your plus, right? This is your incoming current towards the KCL point P, means we have considered plus. Here minus 4 ampere current is there, but it's leaving from a point P, right? Means we
Yes.
have considered what here, Gopal?
Plus 3 minus 4. No, sir. Outgoing current minus 4.
Yes, Gopal?
Yes, sir.
Minus, yes, exactly.
Minus
Minus
4.
4. Again, Gopal, here the current direction is there, showing over here for 10 ohm resistance. What we have considered here?
Minus, sir.
Yes, exactly. Why minus? Because it's outgoing current.
Yes, sir.
That is minus 10 ohm. equal to 0. Then you have to find out simple, you have to separate it out. I 10 ohm
1.
is equal to 3 minus 4. Is what is the current flowing through minus 10 ohm resistor? Sorry, 10 ohm resistor is
One.
minus 1 ampere. It's very simple. There is no logic. Okay, just you have to keep in mind the concept of KCL. KCL means what? You have always keep in mind the positive sign is for incoming and negative sign for the outgoing. It is very useful, right? KCL for uh, nodal analysis. You don't know KCL, then you can't be able to put up KCL in nodal. You are not able to find out the nodal analysis. KCL is very important for nodal, and KVL is very important for mesh analysis. For mesh analysis, keep in mind. Are you getting this concept?
Yes, sir.
Yes.
Yes.
Uh, shall we stop today? Maybe 11:56. You have
Yes,
next
sir.
lab also. Right? You have next lab also, right? Are you getting whatever we have seen today? Right? You have join as early as possible. Just